children, once again welcome back to Physics with Sanoop. See, in this video we are going to discuss all past questions of NEET from the chapter Electromagnetic Induction. See, we will be discussing all the previous questions that appeared in NEET question paper and also see earlier AIPMT questions. Okay, so let's see the first question. The magnetic flux linked to a circular coil of radius capital R, okay, is given. There is an expression we have. See the magnitude of the induced EMF in the coil at t equal to 5 seconds. We have to find only the magnitude. See, induced EMF is actually minus d phi by dt, and phi is given as 2t cube plus 4t square plus 2t plus 5 Weber. Okay, so minus d phi by dt means minus, then 2t cube. So this 2 is constant and the differential of t cube will be 3t square. Okay, next term is 4t square, of which 4 is constant and differential of t square will be 2t. Okay, next 2t, 2 is constant and the differential of t is 1. Okay, next term is 5 being a constant, its differential is 0. Okay, so this is the instantaneous EMF. Okay, if you want to find the induced EMF at any time, you have to put that time for t. Okay, here we have to find the EMF at t equal to 5 seconds. So we will have to put t equal to 5. So in the first term, t square means 5 square, that is 25 into 3, 75 into 2, that is 150. Okay, in the second term, 2t means 2 into 5, that is 10 into 4, that is 40. Then 2. Okay, so it will be 192 volt. Okay, 192 volt. Now let's see what we have next. A square loop of side 1 meter and resistance 1 ohm is placed in a magnetic field of 0.5 Tesla. If the plane of the loop is normal, perpendicular to the direction of the magnetic field. See, magnetic flux linked with a coil means total number of magnetic lines of force passing normally through that coil. Here the magnetic field is normal to the area of the coil. So the flux is flux linked with the coil will be simply the flux density into area. Okay, and phi equal to BA. See, B is given as 0.5. The whole magnetic field is normal to the area. So that flux density into area will give you the flux. Okay, and see the square side is 1 meter. So area will be 1 square. So 0.5 Weber. Next, a big circular coil of 1000 turns and average radius 10 meter. Why average radius? See, suppose see, this is the coil, just like a mosquito coil. See, this is the coil. See, all the turns in that coil need not be of the same radius. Okay, that's why see, it is given as average radius, because all the turns will not be of the same radius. Okay, so average radius 10 meter is rotating about its horizontal diameter 2 radians per second if the vertical component of Earth's magnetic field at the place is 2 into 10 raised to minus 5 Tesla and electrical resistance of the coil is 12.56. 12.56 is actually 4 into 3.14. Okay, then the maximum induced current in the coil will be. See, this is the peak value of voltage NBA omega. And N is 1000 turns and B is given as 2 into 10 raised to minus 5. Yeah, B 2 into 10 raised to minus 5 Tesla, and area is pi r square. Radius is 10 meters, so pi into 10 square. Okay, and angular velocity is given as 2 radians per second. See, 2 radians per second. Okay, now see this 2 into 2, that is 4 into pi, 4 pi. Now let's consider the powers of 10. Here we have 10 raised to 3 into 10 raised to 2, that is 10 raised to 5, and 10 raised to minus 5 will get cancelled. Okay, so the voltage will be V0 equal to 4 pi, that is the peak value, and peak current is V0 by R. So 4 pi divided by 12.56, that is exactly 1 ampere. Okay, so this one. Now let's see what we have next. 800 turn coil of effective area 0.05 meter square is kept perpendicular to a magnetic field. Means the magnetic lines of force are normal to the area. Okay, when the plane of the coil is rotated by 90 degree, see when the plane is like this, the whole lines of force are passing through the area and the magnetic flux will be flux density into area. Okay, the lines of force are like this. Now suppose this coil is turned by 90 degree, then no magnetic lines of force are now normal to the area. See, if these lines are like this, it is not getting linked with the area. See, if this area is like this, then the magnetic lines of force must be like this. But here the lines are tangential to the area. So initially magnetic flux is B into A. When it is turned through an angle 90 degree, magnetic flux is 0. So final flux is 0. Okay. Now let's see. Phi 1 equals NBA, number of turns 800, magnetic flux density is 5 into 10 raised to minus 5 and area is 0.05 meter square. Okay. Now see this 800 into 5, 0.05. 800 into 0.05. This 100 into 0.05 will become 5, into 8 will become 40. Okay. Then 40 into 5, that is 200. 200 into 10 raised to minus 5, that is 2 into 10 raised to minus 3, that is the initial flux. Finally it is 0, that I have explained earlier. Okay. So induced EMF is minus of change in flux. In physics, change means always final minus initial. Okay, 0 minus 2 into 10 raised to minus 3 divided by time is 0.1 second. So we will get 0.02 volt. 0.02 volt. Now a current of 2.5 ampere passes through a coil of inductance 5 Henry. Magnetic flux phi equal to Li. You know, see in electricity, this magnetic flux phi is analogous to linear momentum in mechanics. Time rate of change of linear momentum is force. In mechanics, linear momentum. In electricity, corresponding quantity, magnetic flux. In mechanics, mass. Corresponding quantity here is self-inductance L. In mechanics, velocity. Corresponding quantity here is current. dP by dt is mechanical force. d phi by dt is electromotive force. P is linear momentum, dP by dt force. Phi is magnetic flux. It is analogous to linear momentum in mechanics. D phi by dt is electromotive force. Okay. Now see here we have L is 5 Henry and current is 2.5, so it will be 12.5 Weber. Okay. Now let's see what we have next. A coil of resistance 400 ohm is placed in a magnetic field. If the magnetic flux linked with the coil varies with the time t as phi equal to 50 t square plus 4, the current in the coil at t equal to 2 seconds is induced EMF E equal to minus d phi by dt. See see this is the magnetic flux that we have to differentiate. Okay, 50 t square, 50 being a constant. Okay, then differential of t square is 2t. Okay, next term is 4 and its differential is 0. Okay, when t equal to 2 seconds, we will get 2 into 2, 4 into 50, that is 200. So 200 volt. And current we have to find out, and the resistance is given as 400 ohm. So 200 volt by 400 ohm, that is 0.5 ampere. Okay, now see in a coil of resistance 10 ohm, the induced current developed by changing magnetic flux through it is shown in figure as a function of time. The magnitude of change in flux through the coil in Weber is. See, induced EMF equal to minus delta phi by delta t and current I equal to E by R. Okay, so 1 by R into delta phi by delta t. Okay, magnitude of change in flux through the coil. Magnitude of change in flux through the coil means we have to find out delta phi. Okay, so delta phi is R into I delta t. See in any graph, see the area and the physical quantity represented by the area under the graph is quantity along the y-axis into quantity along the x-axis. In velocity time graph, area is velocity into time. In acceleration time graph, area is acceleration into time. In current time graph, area is current into time, that is charge. Okay. Now see, delta phi equals r into I delta t, current into time. That is the area under the current time graph. So capital R, it is given as 10 ohm, and area, see area under the graph here, it is says a triangle, and its area will be half into base into altitude. Okay, half into 0.1 into altitude is 4 units. So that will be 2 Weber. Okay, so 2 Weber, 2 Weber, this one. The current I in a coil varies with the time as shown in figure. The variation of induced EMF with the time would be. See current versus time graph is given, and see it is plotted for from 0 to capital T. That time 0 to capital T is divided into 4 equal intervals. 0 to t by 4, then t by 4 to t by 2, then t by 2 to 3 t by 4, and 3 t by 4 to t. Okay, see induced EMF is minus L into di by dt. Okay, and this di by dt is actually the slope of the current time graph. See during the first interval 0 to t by 4, see the current time graph is a straight line with a positive slope. For any straight line, slope is constant. So di by dt is positive and constant. So minus L into di by dt will be negative and constant. So 0 to t by 4, induced EMF is negative and constant. See there is only one, see option with the voltage 0 to t by 4 negative and constant. See from during the next interval means from t by 4 to t by 2, graph is again a straight line with a 0 slope. So the induced EMF will be 0. Okay, so from t by 4 to t by 2, see induced EMF is 0. See during the next interval, see the graph is a straight line, means the slope is constant but it is negative. So the di by dt is constant and negative, so the voltage will be constant and positive. T by 2 to 3 t by 4, see t by 2 to 3 t by 4, constant and positive. And during the see last interval, current time graph is a straight line with a 0 slope, so induced EMF will be 0. Okay, everything perfect, only one option, that is A. Okay, next see a conducting circular loop is placed in a uniform magnetic field B 0.025 into 025 Tesla perpendicular to the loop. The radius of the loop is made to shrink at a constant rate of 1 millimeter per second. The induced EMF when the radius is 2 centimeter. Okay, see flux phi equal to flux density into area, that is pi r square. Induced EMF is d phi by dt. Okay, pi and b are constant, so dr square by dt. Okay, pi b, see differential of r square with respect to t is 2r into dr by dt. Okay, so 2 pi, and the magnetic field is 0.025, means it is 25 into 10 raised to minus 3, 2 pi b. Radius is given as 2 centimeter, 2 into 10 raised to minus 2. And dr by dt, the rate at which the radius changes, it is 1 millimeter per second, means it is 10 raised to minus 3. Okay, and now see here we have a 2, this is 2, that is 4 into 25, that is 100. Okay, 100 and this 10 raised to minus 2, that will be 1, or 100 and 10 raised to minus 2 will get cancelled. Okay, what remains? We have a pi here, then 10 raised to minus 3 into 10 raised to minus 3, that will be 10 raised to minus 6. Okay, so pi microvolt, okay, that will be pi microvolt, means pi mu v. Okay, a conducting circular loop is placed in a uniform magnetic field of 0.04 Tesla with its plane perpendicular to the magnetic field. The radius of the loop starts shrinking at 2 millimeter per second. The induced EMF in the loop when the radius is 2 centimeter. Similar question we have just done. Okay, phi equal to b into pi r square, d phi by dt is pi into b, pi and b are constants, then dr square by dt, so it will be 2r into dr by dt. Okay, so 2 pi b r into dr by dt. 2 pi, magnetic field is 0.04 Tesla, means 4 into 10 raised minus 2, radius is 2 centimeter, and dr by dt is 2 millimeter per second, 2 into 10 raised minus 3. Okay, here we have 2 into 4, 8 into 2, 16 into 2, that is 32 pi. Okay, then we have 10 raised to minus 2 into 10 raised to minus 2, 10 raised to minus 4 into 10 raised to minus 3, that is 10 raised to minus 7. So 32 pi into 10 raised to minus 7, or 3.2 pi into 10 raised to minus 6, or 3.2 pi microvolt. 3.2 pi microvolt. Okay. Now let's see what we have next. A circular disc of radius 0.2 meter is placed in a uniform magnetic field of induction 1 by pi Weber per meter square in such a way that its axis makes an angle 60 degree with the magnetic field. See, magnetic field linked with an area is the magnetic field along its normal. Okay. Here, this is the direction of the magnetic field. This is the direction of the magnetic fields. And our area's normal is along this direction. So, we have to get the magnetic field along the normal. Magnetic field along this direction is B. Along the normal, it will be B cos theta, and theta is given as 60 degree. So, through unit area, the magnetic flux is B cos theta. And through an area A, it will be BA cos theta. Okay. B is 1 by pi, area is pi r square, means pi into 0.2 square, radius is 0.2, and cos theta is cos 60. Okay, so cos 60 is 1 by 2, so it will be 1 by 2, that will be 0.02. Okay, 0.02 Weber, 0.02 Weber. Right. Now the magnetic energy stored in an inductor of inductance 4 microhenry carrying a current 2 ampere. See, the energy stored in an inductor is half Li square. This is an important formula. Usually you can expect this question. Okay, U equal to half Li square and U half then 4 microhenry. Yeah, 4 into 10 raised to minus 6. And current is 2 ampere. Okay, so it will be 8 into 10 raised to minus 6 or 8 microjoule. Okay. Now, two conducting circular loops of radii R1 and R2 are placed in the same plane with their centers in coinciding. If capital R1 much greater than R2, why capital R2 is to be kept much smaller than R1? See, this B1 mu 0 I by 2 R1 is the magnetic field intensity only at the center. Only at the center of the loop. If we keep the area of this smaller loop as small as possible, then we can take this field as constant everywhere inside that smaller loop. That will be possible only if the area of that loop is much smaller. Okay, means it must be, see, its area must be at the center of the loop, bigger loop. Okay. Now see, this is the magnetic field due to the first coil at its center. The second coil is kept at the center of the first coil. So let us assume that the field inside the second coil is uniform because its area is very small. Okay, this is the flux through unit area, and the area of the smaller loop will be pi r2 square. So this is the flux through the smaller loop. Okay. See, general formula for the flux is phi2 equals m I1, where m is the mutual inductance. Now we have got two expressions for the mutual for the flux. Here phi2, here also phi2. See, if we have same left side, we can equate the right side also, and we will get m equal to mu 0 pi r2 square divided by r1 square. So the mutual inductance will be directly proportional to r2 square by r1. Okay. Now let's see what we have next. A cycle wheel of radius 0.5 meter is rotated with constant angular velocity 10 radians per second in a region of magnetic field of 0.1 Tesla, which is perpendicular to plane of the wheel. The EMF generated between its center and the rim is, that is half B r square omega. So V is half, B is 0.1 Tesla, and radius is 0.5 square into omega is 10 radians per second. So this will be, this 10 and 0.1 will become 1. Then this is 0.25 divided by 2 means 0.125 volt. Okay. Now let's see what we have next. the magnetic potential energy stored in a certain inductor is 25 millijoule and the current in the inductor is 60 milliampere. This inductor is of inductance. U equals half Li square. So L will be 2U by I square and U is 25 into 10 raised to minus 3 and I 60 into 10 raised to minus 3. I square will be 60 into 10 raised to minus 3 whole square. See, 10 raised to minus 3 we have in the numerator and also there are two 10 raised to minus 3 in the denominator. So this 2 into 1 10 raised to minus 3 from the numerator and 1 from the denominator can be cancelled. Okay, then in the numerator 2 into 25 that is 50 and in the denominator 60 square into 10 raised to minus 3. 60 square is 3600 and only 1 10 raised to minus 3 remains in the denominator. So 3600 into 10 raised to minus 3 will be 3.6. See, if it is 50 by 4, it is 25 by 2 or 12.5. But in the denominator, it is not 4, it is slightly smaller than 4. So the answer will be slightly more than 12.5. So what we have slightly more than 12.5, that is 13.89. Next, a long solenoid has 1000 turns when a current of 4 ampere passes through it. The magnetic flux linked with each turn of the solenoid is 4 into 10 raised to minus 3 Weber. The self-inductance of the solenoid will be. See, self-inductance L is 5 divided by I. We have 1000 turns and the flux through each turn is 4 into 10 raised to minus 3. So the total flux will be 1000 into 4 into 10 raised to minus 3. This 1000 and 10 raised to minus 3 can be cancelled. Then 4 by 4, that will be exactly 1 Henry. Okay. Now see, we have another question. A long solenoid has 500 turns. When a current of 2 ampere is passed through it, the resulting magnetic flux linked with each turn of the solenoid is 4 into 10 raised to minus 3 Weber self-inductance. See, flux through each turn is 4 into 10 raised to minus 3 and there are 500 such turns. Okay. So 5 into 4, that is 2000 into 10 raised to minus 3 is 2 Weber. And see, current is given as 2 ampere. Okay, so the self-inductance will be 1 Henry. Okay, this one. Now two coils of self-inductance 2 millihenry and 8 millihenry are placed so close together that the effective flux in one coil is completely linked with the other mutual inductance between these. See, when flux produced in one coil gets completely linked with the other, then it is called tight coupling, where the coupling coefficient is 1. Then the mutual inductance. Actually, mutual inductance M is equal to K under root L1 L2. K is called coupling coefficient. Less than 1 for loose coupling and equal to 1 for tight coupling. Here the given case is ideal where there is no flux leakage. Tight coupling, K equal to 1 and we have L1 and L2 as 2 into 2 and 8. So the self-inductance will be 4 millihenry. Okay. Next, a conductor of length of 0.4 meter is moving with a speed of 7 meter per second perpendicular to a magnetic field of intensity 0.9 Weber per meter square or Tesla. The induced EMF is capital V, voltage, BVL, this small v is speed. Magnetic flux density is 0.9, velocity is 7 meter per second and length is 0.4. Okay, 9 into 0.9 into 7 is 6.3 into 0.4 is 2.52 volts. 2.52 volt. A varying current in a coil changes from 10 ampere to 0 in 0.5 seconds. If the average EMF induced in the coil is 220 volt, the self-inductance of the coil is, see, E equals minus L into di by dt and L will be minus E divided by di by dt. See, di by dt means final current is 0, initial current is 10 ampere and that change takes place in 0.5 seconds. So this is minus 10 by 0.5 means minus 20. So minus 220 by minus 20. Minus will get cancelled. So it will be 11 Henry. Okay, what is the self-inductance of a coil which produces 5 volt? When the current changes from 3 ampere to 2 ampere in 1 milliseconds. Di by dt, final current 2 ampere minus initial current 3 ampere and it happens in 1 millisecond. So it will be di by dt will be minus 10 raised to 3. Minus 10 raised to 3. And self-inductance is minus E, means minus 5 divided by minus 10 raised to 3, that is 5 millihenry. Okay, 5 millihenry. Now a rectangular coil of 20 turns and area of cross section 25 square centimeter has a resistance of 100 ohm. If a magnetic field which is perpendicular to the plane of the coil changes at the rate of 1000 Tesla per second, the current in the coil is. See flux NBA and magnitude of the induced EMF is d phi by dt, means N and A are constant, so NA into dB by dt. Number of turns is 20 and area is 25 square centimeter, means it can be converted to meter square by multiplying with the 10 raised to minus 4. Okay, and see dB by dt, that is 1000 Tesla per second. Okay, now see here we have a 10 and 10 raised to 3, that is 10 raised to 4 and 10 raised to minus 4 can be cancelled. What remains? 2 into 25, that is 50 volt. And the resistance is given as 100 ohm. So 50 volt by 100 ohm, that will be 0.5 ampere. Okay. A 100 millihenry coil carries a current of 1 ampere. Energy stored in its magnetic field is, see, U equals half Li square. And self-inductance is given as 100 millihenry, means 100 into 10 raised to minus 3. And the current is given as 1 ampere. Okay. So 1 square. So it will be 100 by 2, that is 50 into 10 raised to minus 3 will be 0.05 joule. 0.05 joule. Okay. Next, if the number of turns per unit length of a solenoid is doubled, the self-inductance of the solenoid will become. See, mu 0 capital N square is the total, capital N square A by L, where capital N is the total number of turns. Okay. Now, see, we have, this small n, that is the number of turns per unit length. Okay, that is equal to capital N by small l. So capital N will be small n small l. Capital N square will be small n square small l square by l. So small n square small l. So small n square small l into area. So self-inductance is directly proportional to small n square. Okay, if the number of turns per unit length of the solenoid is doubled, then the self-inductance will become 4 times. Okay. Next, an inductor may store energy, inductor store energy in magnetic field, whereas a capacitor stores energy in electric fields. Okay.